Hello, everyone, and welcome back to the Discovery Garden webinar series. At Discovery Garden, our systems team works to identify and remove barriers that may have performance-related impacts to our clients. They work hard each day to assist our clients in integrating systems in a reliable, economically viable, and safe manner while ensuring performance is not negatively affected. For the webinar today, as always, I will be recording as you just heard, and I'll send out a link to access it later on. Please note your mics will be muted for the duration of the session to eliminate background noise. So my name is Adam Smith, and I'm the Business Development Associate here at Discovery Garden. I've been with the company for about 2 years now, and I've had the pleasure of speaking with most of you. For those of you that I haven't met yet, I look forward to meeting you and talking to you in the near future about some upcoming projects that you might have. So as per usual, we're going to start today with an overview of Islandora and Discovery Garden. And after that, we're going to move into the main part of the webinar, which will feature a discussion on how to improve Islandora stack performance and stability. As always, following the presentation, I'll open the floor to any additional questions that arise. Please type them in the chat window as your mics will be muted, as I mentioned, for the duration of the webinar. So with that, let's start. As I mentioned, let's start by talking a little bit about Islandora for anyone who might be new to the community. And I did see that there's a few new people signed up, so welcome. So the Islandora open source technology stack consists of 3 core components, being Drupal, Apache Solr, and Fedora Commons. The stack also includes a lot of utility components and dependencies as well. Islandora is a very large open source software stack, and it includes many applications. So in essence, the developers of Islandora and the community that supports it are experts at integrating third-party tools into Islandora. So let's talk about a little bit about the core components now individually, and we'll start with Drupal. Many of you are familiar with Drupal, as it is a leading open source content management system with over 30,000 user-contributed modules from almost 100,000 active community members or developers. Active community members are vital to any open source project, and the same can be said for Drupal. People are invested in Drupal, and that leads to ongoing development and ultimately success. Drupal serves as the presentation layer in Islandora. It's how we create a website and how we expose it to the internet. We also use Drupal for collaboration as well. It has a great framework for users, roles, and permissions, and we use that for workflow activities, and it really does integrate in with a lot of other functionality within Islandora. So in essence, Islandora is a suite of Drupal modules that allow us to build repositories on top of Fedora Commons. Now these modules make it possible to build, populate, and configure a digital repository without the aid of a developer. So next is Apache Solr. So Apache Solr is used for discovery within Islandora. Solr is very powerful, very flexible, and configurable. It's used on some of the most heavily trafficked websites and applications worldwide. Key features of Solr include full text search, search faceting and filtering. It's highly scalable and fault tolerant, and provides near real-time indexing. For example, if we ingest an object into Islandora, it's going to be indexed within Solr almost immediately, and will become searchable probably within 30 seconds after ingest. So the final core component is Fedora Commons. Now this is the layer that stores and preserves all of our digital content. Fedora Commons is purpose-built for data preservation and long-term data accessibility. Some key features of Fedora Commons include auditing and fixity checks, RDFX, ML support. We're able to scale Fedora Commons to millions of objects. It has support for virtually any file type, and it's built for interoperability. That means you can export or migrate your data in a format so that it can be used or stored elsewhere should you choose. So as mentioned, those 3 core components make up the open source technology framework. And we like to call it a framework as it really is the integration of components working together. Now organizations all over the world are using the Islandora framework to build repositories. Now some of these instances are customized in order to meet specific needs, and some are not customized as the software is very, very usable out of the box. Now people are scaling these repositories into the millions of objects, and they continue to have these large repositories perform very well. It helps to create fast, usable sites that are meeting customers' expectations. So as promised, now a little bit about Discovery Garden. Discovery Garden, we are a service provider of Islandora. We work to remove barriers to using the open source technology. We launched in 2010, and we are a partner in the Islandora Foundation, which is the nonprofit entity that fosters the Islandora code. So since we've launched, we've contributed to over 90% of the Islandora code base, which we've written here at Discovery Garden on behalf of our many customers. We offer a lot of services that relate to an Islandora repository as well. I'm going to send out a complete list of our services, which can be found on our website as well, but I'll send out the information package after the webinar today along with the recording. Okay, so moving right along, it's now time for the main presentation. It is my pleasure to introduce Luke Taylor. Luke is the systems team lead here at Discovery Garden and has a wealth of knowledge gained through years of experience in working with the Islandora stack. He has been with the company since the fall of 2012 and has introduced technologies such as Puppet and Vagrant that have revolutionized the way we work here at Discovery Garden. Luke has almost 15 years of experience in systems development and is extremely well regarded within the Islandora community. So welcome, Luke.
Thank you for the introduction, Adam, and welcome everyone. Today I'll be talking about maintaining and growing the Islandora 7X stack, which it makes use of Fedora 3X. For the purposes of this presentation, Claude and Fedora 4 are considered out of scope. We'll be touching on various performance enhancements as well as common gotchas that we have encountered over the years in dealing with multiple Islandora and Fedora installations. For those of you who have attended my presentation at IslandoraCon, some of the material being covered might seem repetitive. Hopefully, I'll be able to cover off additional material that may not have been as well covered in IslandoraCon due to time constraints. To start off my presentation, I'm going to give a quick high-level overview of the various components that get used in the Islandora stack to help give a better understanding of what we're going to discuss later. So these are some of the main high-level components that make up the stack. Depending on what content models you're using, you may not have some of these components, such as the image server. Islandora is an open source software framework designed to manage, interact, and interface with digital repositories housed in the Fedora Commons application using APIs. Islandora itself utilizes Drupal as a platform and is made up of a number of modules and libraries that provide user experience and a wide range of functionality. Islandora needs to be able to access the Tomcat containers that house the Fedora Commons repository and as well as Solr. Generally, you would access them over port 8080 or 8443. Drupal is a widely used web content management system, or CMS, that runs in an HTTP server. It needs to run on a front-end system that has HTTP or HTTPS exposed to its desired user base. Drupal has its own database, or in some cases, you may have multiple databases if you are using multi-sites. Multi-sites is when you have multiple sites housed within the same Drupal installation on the same server. I should point out, while Nginx can be considered superior in many ways, it is highly recommended that you use Apache instead when dealing with Drupal and Islandora. The reasons for this is most, if not all, supporting documentation for Islandora assumes you're using Apache and not Nginx. Islandora testing and development has generally been conducted on systems using Apache. Most importantly, you'll notice that Drupal 7 and many of the contrib modules use various htaccess files. The htaccess files get utilized by Apache, not Nginx. While it's possible to port these configurations, it could be challenging to maintain since some of those files could change when you're updating your installation, and you may or may not be aware of it. Fedora Commons, when we're talking about Fedora, don't confuse it with the operating system. We're actually talking about Fedora, the application. It stands for Flexible Extensible Digital Object Repository Architecture. And what it is a repository architecture for storing, managing, and accessing digital content. It's a Java web application which runs inside of a servlet container, such as Apache Tomcat. Fedora provides APIs, which can be accessed normally over 8080 or 8443 to Islandora. Islandora uses a module, or a library rather, called Took to interact with it. Fedora creates and manages and accesses a data stream store, and object store. These are actual directories that you can find on your Islandora installation. And these directories make up the actual data of the repository. And they're normally housed on attached disks or mounts that are large enough to accommodate the immediate and anticipated growth, usually with the capacity to scaling to larger sizes as necessary. The location of these can be moved if required, provided that the appropriate configurations are changed. Generally, you can do it with just a symlink, or you can modify the Akubra LL store file, which can be found in the Fedora server configuration. It should be noted that multiple Fedora Commons servers can read the same data store and object store. However, only one Fedora should conduct management level read-write tasks. I should point out that if you're going to change the Akubra LL store file, that you should also update your gsearch configurations to point at where it is. That's why I normally recommend doing symlinks over modifying the Akubra LL store file. Fedora also has its own MySQL database for application management that you'll need to have it be able to access the MySQL database server. It also needs to access the database server to be able to hit the various Drupal databases. Fedora also populates and manages a triple store, which is also known as the resource index or RDF store, which can have Sparkle or ITQL, in the case of Mulgera, queries run against it in order to retrieve meaningful information about your data in the form of triples. If that's not in place or working, Fedora won't be able to start or function properly. Solr, as Adam mentioned earlier, it's an open source search platform, which runs also as a Java web application. It provides a search index, which can be used by many Islandora components in order to provide search features to front-end users. Both Islandora and Fedora gsearch require port access to the Solr server, generally 8080. Depending on the use case and configuration, Islandora can make use of both Solr and Sparkle queries. So depending on what you're doing in the application, you'll either have queries going against Solr, or in some cases, you may have them going against the triple store. Generally speaking, you should always try to do Solr queries versus triple store queries if you have a choice between the two, because Solr is much more performant. We'll be touching more on this later in the presentation. Fedora gsearch is also a Java web application, which listens for update messages generally from a JMS provider, such as ActiveMQ, which is actually included in Fedora. It takes these update messages and transforms them into something that Solr can use to update its index. Because it's reliant on the JMS provider that's bundled in Fedora, generally speaking, you would have your Fedora gsearch deployed on the same server as the Fedora where you're ingesting. The stock community install of Fedora, as I mentioned, utilizes Mulgera as its triple store. You'll find it's currently used by the vast majority of Fedora installations. However, it does suffer from a number of drawbacks, including it not being an active project and it lacks scalability. While Fedora Commons documentation suggests that a remote installation of Mulgera is possible, we have had mixed experiences with it. And as a general rule, if we were to use Mulgera, we would just use the stock Mulgera installation that comes with Fedora. To address a number of the drawbacks of Mulgera in terms of scalability and support, in larger installations, we've made use of alternatives such as BlazeGraph. BlazeGraph has a number of capabilities and features that Mulgera lacks, including being active and being able to cluster. We'll discuss more on this later. The image server, currently, the only real one that is supported in the community is Adore Jatoka. There is work taking place to try to get Cantaloupe working. What the image server does is it resolves TIFFs and other image types for Islandora viewers such as OpenSeaDragon. This runs as a Java web application, which is normally housed in Tomcat. Since Adora Jatoka is a dead project, I'm very interested myself in the work of Cantaloupe. It'd be nice to see that or get that working once all the work's done on it. I mentioned derivative generation. When I actually say that as a part of the stack, it's actually referring to all the various binaries and open source applications that we use in order to generate derivatives, depending on what content models you're using. Some of these examples could include FFmpeg if you're doing video. There's Tesseract if you're ingesting books. There's FITS. There's a number of different binaries that get installed depending on what content model you would like to use. If you're unsure and we're doing an installation for you, normally we include most of the common content models that most people want. If you come to us and you're only looking for certain content models, we can tailor the installation more around them. So I'm going to talk about different ways that you can set up Islandora. The vast majority of installations just start out as a single server install, which is able to be scaled out later. There's no real fast rule in terms of if it should be on one server or two servers or three servers. It can vary a lot depending on what content models, solution packs, what your internet user traffic is, how many objects you have. There's a lot of stuff that can have an impact on whether or not you might want to go with one server or multiple. Some people, because they're on a budget, may just want to start out with one, and it is possible you can scale it out and you can scale it back. You're not necessarily tied to one server. You can break this out into 5, 7, or more servers as needed. For some people, if you know you have heavy site traffic or you're going to be doing heavy ingest, and if your anticipated object counts are going to be over 100,000, some people normally would start out with 2 or 3 servers because there's a very real risk of significant performance impact to your users when you're doing ingest. Which brings me to the next slide. Now this represents a more involved installation that's been broken out to help scale the stack. You'll notice on the right-hand side, you have a staff front-end server. So that would have Drupal installed, potentially with or without multi-sites. And it would have all the binaries and everything needed in order to do ingest. We also normally would install Gearman on that server, so you can actually have a queue, so you can have multiple CPUs working on some derivative generation tasks that don't thread. So you have like Tesseract, for example, you would have that just on one CPU. With Gearman, you can have actually 4 Tesseracts running. If you were not using Gearman, you would only have one running and it'd be bound to one CPU. Because it is doing heavy ingest, I have it broken out, so there's 2 front ends. So you have the public front end, and then you have the staff ingest front end. So the public front end just has caching. There's no ingest taking place in that. This is where your actual users out in the internet are viewing your site, and it's very performant, very fast. It has a read-only Fedora to serve up the actual objects, and because of that, neither one of those servers should see any impact due to heavy ingest. The bottleneck in this scenario likely is going to be your storage, or potentially your database, but ideally, if you have a separate database server, it's tuned properly and potentially clustered. So with the read-write Fedora, it would house your G-search, and when you're ingesting, the Fedora G-search will be updating your remote Solr. So you actually have a remote Solr server that is being utilized by both front ends, and then you would have a BlazeGraph server that both Fedoras are actually using the same triple store. One of them can only has read-only access, the other has read-write. Same with the actual Fedora database. Both Fedoras will use the same database, and in this scenario, you could be doing all your ingests, Solr's getting updated, BlazeGraph's getting updated, and your public will see everything as you're doing it without having a performance impact. Now, this is a pretty involved install. Maybe you don't want this many, so you can combine some of these services on the same server. You might want to have your database, BlazeGraph, and Solr, and Fedora all in the same backend server, or maybe you want to break it out. Generally, we do an assessment and we look at a person's situation or an organization's situation, and from there we would decide if this type of solution is where you're at, or if you want to go with something a bit scaled back. Generally speaking, most people start conservative with 1 or 3 servers, and they grow from there. So this slide, I'm describing a couple different components here. So if you want to use remote Solr, you need to make sure you use the latest G-search, so anything above 2.8, preferably head, as later I'm going to describe, because there's issues with some of the older G-searches. So you just need to make sure you use the latest G-search. You edit the FGS index base in the index.properties file, and to point at the remote Solr. What's funny about it is, though, you still have to maintain a dummy index on the same server as Fedora G-search. It doesn't have to actually have any data in the index. It just needs to be there, or it's going to throw errors and not work right. It's just one of those weird gotchas when you got to go do this. You don't have to have Solr running. Once you have it pointed at the remote Solr, you can remove Solr off your existing G-search server and just leave the dummy index there, and it should work fine. With BlazeGraph, so as I mentioned, this is used to replace Mulgera for performance and stability games. Depending on, there's 2 different options. There's one that discoverygarden made. We partnered with the University of Pittsburgh, and we made the Trippy Sail implementation of it. Oh, jumped ahead of a slide there. My apologies. The other implementation is Trippy Sparkle, which was done by the Smithsonian. Both implementations are good. In terms of discoverygarden, we've only done extensive testing on the actual discoverygarden implementation. I know the Trippy Sparkle had some issues with namespaces, which meant it needed some additional work, but I think they might have fixed that. But I haven't took a look at the repository in quite some time. One thing I should point out with BlazeGraph is that generally the biggest performance boost you're going to get is if you can replace your queries, your Solr, your Sparkle or ITQL queries with Solr. If you can replace those problematic queries with Solr, you're going to get far more performance gain than if you were just to swap out Mulgera with BlazeGraph. The real benefit to swapping Mulgera for BlazeGraph is the ability to scale. So if you're finding that your triple store is a point of contention, moving towards BlazeGraph allows you to separate it from the stack, put it on its own server, cluster it, and you could throw more resources at just the triple store. It also makes troubleshooting a lot easier. The more broken at the stack, the more easier it is to see where the bottlenecks are. As I mentioned, depending on what you're doing in the stack, you're going to be using either Solr or Sparkle. or ITQL in the case of Mulgera. Here's a few different examples that if you're to go through your Islandora configuration in the UI, that you should select if possible to provide a significant performance boost. So in the collection solution pack, there's an option to switch from Sparkle to Solar for display generation. So when you're bringing up your collections, instead of trying to do an order by across quite a few objects, let's say you had a collection with like 10,000 objects, it's going to take, if you're just using Sparkle, it's actually trying to do an order by, and it's going to pull them all out and reorder them, and it can, the more objects you get, the worse it's going to perform in that particular collection. If you're running into issues with that, if you go into the collection solution pack properties, you can actually switch it to Solar, and it should be significantly better. When you're doing that, you might have to, there's a few other fields there you might have to fill out so it knows what it's actually, what it's going to order it by. There's also the Islandora OAI, which also has some performance issues with Sparkle. If you're using that module, I'd again recommend using Solar. Page content module, it can also use Solar to derive pages and sequence numbers. So when you're bringing up a book and it has a bunch of pages, it can perform a lot better. Breadcrumbs. This is actually fairly significant. If you have a site with like 500,000 or 1 million or more objects, you could, it can actually slow your site down to the point where it's almost unusable. There's an option to switch it to Solar. I mean, if you don't need breadcrumbs, I would just disable it. But if you do have a use case, definitely switch to Solar. And your site should be usable again. There's also a number of quick caching options you can enable in Drupal, which work fine. So under configuration, development, performance, there's a few different options in there that you can select that I'd recommend. There's also memcache and varnish. I would approach those a little more cautiously. Do not use the stock VCL that is included with varnish. It doesn't invalidate objects properly, and it could lead to stuff being cached that shouldn't be, and you could run into other issues. So if you're going to use varnish, the stock VCL file that comes with it actually needs to be customized. So some of you may have seen this error before. It's a fairly common one, and it's tricky to actually troubleshoot. It's very intermittent. It seems more common on 3.6.2 and 3.7.1 installations of Fedora. However, it also can occur on 3.8.1 installations. Generally, when this happens, it can cause your Fedora installation to destabilize, and the only way to get it working is to restart the Fedora. Or it can cause, you might see that Solar stops updating. You might have, and if you're to check your Fedora log, you're going to see this error message over and over and over again. The reason for it is because that the parser is not thread safe. And if you look through the references in the slide, it outlines where the issue is. And through the work of Adam Vesey, he set up this new repository that I have linked there. There's actually a few different fixes included in this repository. So there's the XML user file module, and there's also the Drupal filter, which I'm going to follow through on the next slide. So along with fixing that XML user's file module error, there's also a very important fix in this module. I should point out that this is free to everybody. It's open. Anybody can get it and view it. Just make sure you follow the README and follow the instructions closely, because there's quite a few changes you have to make to implement it. This is a fairly important fix that's in it. This is with the Drupal filter. It's what the stack uses to authenticate Islandora to Fedora. So it allows Fedora to authenticate your user against the actual Drupal databases. So if you're actually to look at the file, the Drupal filter file, there's a separate connection entry for each Drupal database. And one of the issues with this is that can query all the Drupal databases for each authenticator request to Fedora, which makes a very poor use of database connections. So if you're a site with a lot of multi-sites, many users, a lot of activity going on, maybe you have some like bulk ingest, it's going to be hitting the Drupal databases a lot, and it's a very poor use of your database connections, and it can cause issues and potentially destabilize your server depending on what you're doing. It's also a security risk, because if you have the same username in multiple Drupal sites, it might authenticate against the wrong database. So the way it works is it's going through each connection entry, just looking for a hit. And once it gets a hit, it's going to assume that's the database it authenticates against, even though it might not even be the same user. So there's a real risk that users with the same username in each database might be able to access each other's private objects. Again, it's the same repository. The details on how to implement this part of the fix is there. I'd also like to take this time just to give a special thanks to BCLN, WRLC, the University of Missouri, and University of Connecticut for helping partnering with Discovery Garden to work on this fix. Okay, next I'd like to talk a little bit about ingest and updating the index, the performance around that. Here's a couple different modules from Discovery Garden that I would recommend you use. If in particular, if you have a server with a lot of CPUs and you're not making good use of them, Islandora job is great because you could set up Gearman, so it's actually making use of all your CPUs. I usually start out conservative. So if you, let's say you have an ingest server with 8 CPUs, maybe start off with 4 workers versus 8 and see how it works, because you don't want to overwhelm the other parts of your stack if you're trying to do too much at once. So there's a lot of advantages with Islandora job. So you can have multiple workers. The ingests are much faster. Or I should correct that. The derivative generation is much faster because you can have multiple workers chewing away on a queue that exists in your Drupal database. Islandora G-Searcher. What this does is it's an actual way to update G-Search directly without having to rely upon ActiveMQ, which, as I mentioned earlier, is the JMS provider that comes wrapped up with Fedora. A lot of the times, as Adam mentioned earlier, normally when you ingest an object, within 30 seconds, it should be in your Solr index. That is not necessarily always the case. If you have a very large job running, you might have a backlog of objects in your messages in your ActiveMQ that G-Search is chewing away on, and it could take a long time for the Solr index to be completely updated, or it may never completely update if you're constantly ingesting content. What Islandora G-Searcher does is it allows you to actually disable the JMS provider in Fedora, and in doing that, it offers significant performance increase. We've done a number of tests internally, and the performance increase is about 50%, and it allows you to see the objects in the Solr index right after the ingest is completed. So once the job's done, you can actually look at your solar and it'll just be there. There's no more waiting or questioning, is this ever going to update? As I'm sure many of you know, ActiveMQ at times can mess up. Sometimes you actually have to nuke it and update your index, depending on what state it got in. Maybe your Fedora didn't shut down properly and ActiveMQ got all messed up. It's a common problem, and with implementing Islandora GSearcher, you can help avoid some of these issues. There is an increase in post-batch processing. However, you're unlikely to notice that increase versus the overall 50% performance increase. Some people may decide to leave ActiveMQ still enabled. The reason for that is if you disable ActiveMQ, any changes you make directly to Fedora, not going through Islandora, won't be reflected in the Solar Index because it won't have anywhere to send its messages. So if you're somebody who makes a lot of changes using Fedora admin, for example, you would not want to disable your ActiveMQ because it just won't work. A lot of people sometimes still use GSearcher, Islandora GSearcher with ActiveMQ. The reason for that is because they like seeing their objects directly in Solar without actually having to wait for ActiveMQ. They just won't see the performance increase because ActiveMQ will still try to put the same updates into Solar again. It doesn't actually change anything. It just tries to update the index again, and the changes are already there. I'm going to talk about a couple of gotchas here. So with GSearch, if you look at those two commits, if you were to look at those reference commits, there's been a number of changes in Tomcat where it's a lot more stricter on what characters it accepts. And in doing that, if you were to use anything above Tomcat's 7.7.2 or 8.39, what will happen is it will seem like GSearch is working. When you're ingesting an object, it will update the index, or when you do your initial index or update index, if you're starting with a new repository, it seems like it's working, but if you go to update or modify any objects, it actually doesn't work. It throws errors and it just won't update the index. We've replicated this problem on 2 different servers that were actually set up on 2 different operating systems with by 2 different people. So we've definitely confirmed the issue, and we attempted to put a pull request against GSearch itself, which is referenced here as well. But unfortunately, because Fedora 3X is no longer being maintained, we ended up having to do a fork because we couldn't get somebody to merge the change. So if you look, there's a discoverygarden fork of GSearch that's mentioned here that is being maintained. Another important gotcha I want to point out here is using AWS S3 to mount as an actual file system. There's quite a bit of interest in this due to the significant cost savings if you're hosting in Amazon. When you use S3, generally it's a blob store, so you're normally using APIs to interact with it. It's not a file system like like an attached disk or something like that. It just doesn't work that way. There is a number of file systems out there, or tools I should say, that mimic a file system, and one that we've used a lot of is YAS3FS. If you attended the Islandora Con a couple years ago, Brad Spry's presentation discussed using it as a file system. Given that it's not an actual file system like ext4 or BTRFS or one of your common Linux file systems, I would approach this with caution. And generally speaking, for my own purpose, I still consider it experimental.
and so I just be careful when you're using it. When you're setting it up, make sure you always run it in debug mode first. What I've seen happen is it looks like it's working. You can see the actual mount, and it's writing to it. However, if you go to look at the actual S3, the buckets are empty, or it's not updating the actual bucket. So definitely make sure you run in debug mode first to see if there's any oddness going on. Another big gotcha is make sure it remounts properly if the system is restarted or if any services are restarted. What I've done in some cases is I've created a script that basically sets it up again if it sees that it's not mounted, and then I just threw it in the Tomcat init script so that when Tomcat's starting up, before it starts anything, it checks to make sure it's actually mounted. I'm sure there's better ways of doing it. That's just the way I found that works. I've never actually seen this myself. However, when I was talking to Brad Spry and Gavin, there has been mention that there's some sort of object size limitation when using it, and it's 60 gigabytes for ingested binaries or videos. I haven't actually seen this myself, and I'm not sure where that limitation is actually coming from because S3 supports much larger objects than that. Something to keep an eye out for because others have mentioned it. I just haven't seen it myself. The next point is particularly important. Some people may choose to mount just the data stream store to S3 and leave the object store on EBS, which is the file system that comes with Amazon for better performance. The issue here is that if the data stream store and object store get out of sync, you're not going to be able to rebuild your resource index. So let's say you're taking snapshots of your system, you have a disaster, you revert to a snapshot, you bring the system back up, your object store, which is sitting in the snapshot, is going to be potentially in a completely different state than what the data stream store is. So when you go to rebuild your resource index, it's going to blow up. It's not going to work because you're going to have stuff that might exist in one but not the other. I have gotten it working where both the data stream store and object store are mounted in S3. However, there is a performance hit, but it seems to work. So if you're going to go the route of having the data stream store in S3, I definitely make sure you have alternate backups aside from just the snapshots. And this actually brings us to our next slide I'd like to talk about a bit. So Discovery Garden has developed a tool that we call the Islandora S3 backup. Don't let the name mislead you. It can be S3 or Glacier. And what it effectively does is it provides the ability to back up repository objects and data streams directly to Amazon S3 or Glacier. Your server does not have to be in Amazon in order to take advantage of this tool. You might have a local server in your site that you may want to back up to Amazon. There's a number of advantages to using Glacier over, let's say, tape or other forms of backup. The big thing with Glacier is that it has it's self-healing, it's extremely redundant, and it's extremely cheap. It's like not, if you actually go in and look at it, you'd be surprised that you could have like terabytes in there and it might cost you 20 bucks a month. Like it is very cheap. So currently what we do is we have OBJs. So that's your original object. When you ingest into Islandora, depending on the content model, you'll have an OBJ, and then based off that OBJ, there'd be a lot of derivatives generated. And it's those derivatives that your actual public, your end users, use to look at the data. So when they're browsing the site, they're looking at pictures. Normally, they're looking at the derivatives, not the OBJ itself. Also, another thing that we tend to back up is the archival Foximal. And we could have that so that you can have it versioned so that every time you make a change to an actual object, it could store a different version of the Foximal. There's also arbitrary rules that you could set up so that you may want this to happen ad hoc, or you may want to have it using the rules. You could have it so that when you ingest, it automatically backs up, or certain changes you can have it backed up. There's the module comes with a lot of fairly robust rules that handle most use cases. However, you could tailor it any way you want. Another thing this module does provides checksumming and optional regular fixity checks that could be set up in a cron job. As I mentioned, you can use Drush to do ad hoc backups. You can also do a lot of functionality through the UI. You can restore directly from Glacier. Also, optionally, for some people, they don't want to bother paying for the OBJ since they're looking at the presentation side of things. They may only want the actual derivatives on the more expensive disk. So what you can do is you can actually have it set up so that once it's confirmed that the backup is in S3 or Glacier, that it actually will automatically purge out the OBJ. So you would already have your derivatives generated, the OBJ is backed up, it's returned to checksum, and then it can be purged. Completely optional. Some people like doing it, some people do not. It just depends on how many copies of the object you want.
All right. Well, thank you very much, Luke, for the presentation. There was definitely a ton of useful information in the deck today that I'm sure everybody's going to learn a lot from and have great takeaways from this webinar here. So with that, I'd like to open the floor to any questions. As mentioned at the beginning of the call, if you want to type your questions in the chat window, Luke or I will gladly read them out loud. While we're generating some questions, I just want to talk to you a little bit about a special offer that we're going to introduce today. The S3 module that we have here at Discovery Garden that Luke just discussed typically costs $5,500 US dollars to install. We're offering today, if you are able to execute a contract for that module within the next 30 days, we will take $500 off the price of that. For anybody on the call, and I know there are a few that has already bought the S3 module from us, we're going to credit you with 2 hours of development time that can be used for whatever you like in regards to training or custom development with your site. So if you want any more information on that special offer, you can check the information package email that I'm going to send out later on today with the recording to today's webinar. I don't see any questions generated yet, which typically means, Luke, you've done a great job.
Or maybe I lost them.
I think it's probably more of the former, but that's great. If no, oh, there's a question. Is the Islandora S3 backup module available as a module? Yes, it is. As I just mentioned, it is something that we offer typically at a cost of $5,500, but check the information package that I'll send out later on today for information on that special offer. We have a viewer that was at Islandora Con that missed the session and glad to see it now. So, well, we're glad we could provide it again. Luke's giving the thumbs up, so we're happy to do so. We'll give it a few more seconds to see if anybody else has a question.
Since we have a little more time here while we're waiting for questions, there's a few other little gotchas I'd like to point out that I was going to add in. I just wasn't sure if I had enough time. A common problem I've seen across a lot of Islandora installations is where people are trying to work in solar with views. You might have it so where your autocomplete times out when you're trying to add fields, or it might white screen or hang up. There's actually a fix that went into the basic solar configs back in December that takes care of that. The reason for it is that it's adding the is sequence to the fields, and it's creating way too many fields, and it's actually causing the loop handler to get extremely large. you can actually see it where it can actually crash your site. You can white screen. In particular, if you're adding a solar view and it wasn't set up right, or it's hitting the loop handler, it will crash your actual your PHP. It will white screen.
All right, library says, total newbie question. Can I run Drupal from MAMP using MySQL provided through MAMP and Fedora using a separate install of MySQL? And will that cause problems with Fedora communicating with Islandora or Drupal? Just going to open up.
So do you have it, like, I'm assuming, is it running on a Windows server, I'm assuming?
Mac or
Mac.
Linux.
I haven't actually tried getting the stack working in MAMP, so I'm not entirely sure how that would work. So I can't really provide any more information on that. I haven't actually ever tried that myself.
Something we can follow up on for sure.
I mean, assuming that there's no network issues. I mean, if it's not going to work, it would likely be some sort of network communication issue, as you mentioned there. I haven't done a whole lot with myself. I normally have like my own Linux server I'm just working off of, so I don't normally use MAMP.
Next question is, any issues with SSL? Special issues?
Yes, I actually should bring up SSL. With SSL, it breaks Jitoka a lot. If you're using SSL on your site, you're likely going to have Jitoka issues. A lot of that comes down to that Jitoka, when you're using it, it calls back to Islandora to retrieve the object. It doesn't actually go to Fedora directly. It still goes through Islandora. So when you're going back to Islandora and you're using SSL, Tomcat doesn't trust the cert because it doesn't know what it is. So it rejects it and you'll have your Jitoka fail. There's a number of ways to approach that. You can have Tomcat trust your cert. If that works for you, great. In a lot of cases, depending on where people got their cert, I have seen issues where it had issues with the chain or it just doesn't trust it no matter what we try. And to work around that, there's a lot. You can get kind of creative with your Apache configurations, and you can have it so that the Jitoka portion, when it's calling back to Islandora, is actually HTTP. So you could have and that's just internal communication to your network. So nothing's actually going to be exposed publicly without SSL. It'd be only on your server itself. But there is workarounds you can do if you can't get it to trust the cert. The module for Solar Views, it was actually the Solar configs. So a lot of people in the Islandora community use Discovery Garden's basic Solar configs, which is available on our GitHub. You would just want to get the latest for whatever version you're using. The fix for Solar Views went in back in December. Generally, it's a good idea to keep your code fairly updated because there's a lot of important fixes that get put in over time. Another good example, this is an older fix. I can't remember when it went in regarding Solar. There's a fix for the Solar nav. And what happens is your cache gets extremely large to the point where your MySQL server is crashing. And if you look at the actual size of the tables, you know, it's huge. And you might see your IB data 1 file in your MySQL folder. It could be, 40 gigs. And that's because of an old Solar nav bug that basically puts too much in the database tables for your cache. That should be fixed. That was fixed, I think, a couple of years ago. So if you have super old code and you see that problem, that's likely what it is. A lot of people had that issue.
Viewer number 9 is asking, what is the high-level setup for a read-only Fedora in the multi-server setup you showed? What is the general high-level approach to keep the two Fedoras synced?
The fedoras will actually just stay sync because what you're doing is one fedora is going to be looking at the same resource index as the other fedora. They're both also looking at the same database. Just one fedora you have as read-only. So they're always in sync. They're looking at the exact same data. You're going to be using NFS or something similar to basically expose the object store and data store to the other fedora. Just make sure it's read-only. There's actually a number of, you can do some changes into Exactmo as well to make sure that no APIM or destructive tasks go against the read-only fedora. In terms of special updates, if you actually look at the Trippy the Trippy sale repo on Discovery Garden, the wiki, there's actually step-by-step instructions on how to go about it. Depending on if you're going to use a remote Blaze graph or not, I generally always pick the remote option because it still works just as fine even if it's local.
All right, viewer number 7, any additional updates on the development status for Adore Joker replacement?
I think Diego's working on it. I haven't heard any additional updates recently. I'm sure Discovery Garden herself, or if somebody wants to partner with us, I mean, we could try to get the move the ball along with that.
Yeah, absolutely. It's something we floated to a few clients, but if anybody else there is interested,
it's something we're definitely interested. Just right now, there's other drivers.
Viewer number 9, follow-up. Yes, you mentioned earlier how the single storage mount block would be a bottleneck.
It can be. The shared resort, like Blaze Graph, and can be clustered. You can increase it. Your databases, you can cluster it. You can tune them. There's lots of things you can do there. Same with Solar. You can also cluster it using Zookeeper. Your storage, however, if you have really bad storage, it's going to be, you could have issues. If it's not able to withstand all the writes from the other Fedora, and it ends up causing contention issues with your read-only Fedora. I mean, it varies by organization, but assuming you have a really beefy storage solution, it shouldn't be a bottleneck.
So viewer 9 also says, what is Luke's IRC handle and GitHub username so I can follow your work? We can send that information in the follow package.
Sure.
Also follow him on Instagram.
I don't know if I have an Instagram.
All right. Yeah, no, we'll get that information in the package following up later on today. So that takes us right to the top of the hour. Thanks for tuning in. If you have a question that you didn't get a chance to ask, just shoot me an email and I'll get it in front of Luke and we'll get an answer to you. We're going to take a little break from the webinar series for the summer, but we'll be back in the fall with our next installment, so everybody can look forward to that. So with that, thank you very much to Luke for leading today's session, and have a great summer, everyone. Bye-bye.